Hello everyone. Today I will be going through a signal processing circuit for this video. This is the circuit that I have configured. For the overall signal flow in this circuit, it goes from the sensor, which is the bio-amp that we are using, followed by the TP1, which is the testing point, which then goes into the IC1A, which is the TL072. This works as a preamplifier. So after this, it goes on to TP2, where we test the point, and then it goes into the IC1B, which is the TL072 again, which is for the variable gain amplifier. So after this, it goes into the TP3, and then it goes to the IC2A, which is the TL072, which is the active filter. And then it goes to TP4, and then it goes into the volume control port, a component of the volume control component of the overall signal flow. And then finally it goes into the output, which is the given output audio amplifier. So overall, this is how your circuit will look like. Okay, so our first part is a sensor. So after doing more research, I've realized that in our given circuit, it is a piezoelectric sensor. So what is this? A piezoelectric sensor is a sensor that converts mechanical stress, such as pressure, vibrations, into electrical signals for using piezoelectric effect. So the outcome will result in a very small voltage, high impedance, and lots of noise. Thus, with these conditions, you cannot connect it straight to a speaker. Thus, we have to go through all the steps needed. Okay, so I have drawn this, which is the given circuit, that the first part, which is the input. So what is R5 and R6 for? So R5 and R6 actually work together to form a voltage divider. Basically, the whole purpose of a voltage divider is to create a reference voltage biases the op-amp and allows operation from a single supply, which is from here. Okay, so the next component is C1. What is C1 for? So C1 works as a coupling capacitor. So this coupling capacitor basically blocks DC while allowing AC signal to go through. so this is all for the sensor. Okay, so let's look into lab 3, which is our first component. So let's break down the name, active preamplifier. So the active means that it's made of an op-amp, while the preamplifier is basically to make a small signal amplified into a bigger signal. Okay, so let's look into the lab. This is our given configuration, right? So first question, why is TL072 used? It has very high input impedance and very low noise, which makes it ideal for this situation where you're trying to actually increase the voltage of this input to show and like easier to see and express. So I've gone through this part where this is the VDR, voltage divider rule. Okay, and then let's look at this circuit. Actually, since this negative is connected to the resistors, this is the negative is connected to the output. This is a non-inverting op-amp. So using this R2 and R3, we can actually get the gain, where the gain using the formula for non-inverting is 1 plus R2 over R3 equals to 23. So this actually causes a band pass of 16 Hz to 1 kHz. What does this mean? This means that the circuit will best work when it's in between this range. This is evident in the next page. So these are the values that I've gotten from the lab. As you can see, the gain is mostly around here of 40 Hz all the way up to 1 kHz. And this is my graph. From the graph itself, you can tell that this is a band pass where 23 is actually near 23 is our cutoff. Thus, using the video next, I will show how what changes when frequency changes as well. The next component of this circuit is this. This is let's say a bridge in between lab 2 and lab 3. So what does this step do? Firstly, there's a VDR. There's always a VDR to ensure smooth circuit, a smooth signal. Secondly, there's this part, which is a non-inverting amplifier. The formula for the gain of this amplifier is AV equals to 1 plus potentiometer over R4. So one good thing about this circuit is that the potentiometer is adjustable, where you can actually change the gain of the output using the potentiometer. So this whole purpose of this circuit is to adjust gain, and that means that the user can control the sensitivity or the amplification. Hello, today we're going to go through lab 3, which is active filters. So the whole point of active filter is to change a curve, for example like this, it's like it's wavy into a curve that is smooth. Okay, so that's what a filter is. So the filter circuit is part of the signal processing circuit, and it has a filter, which is a frequency selective curve that allows only a selected frequency to pass through. So this is the formula for the filter for Butterworth. Okay, so let's go look at the lab. We had to patch this circuit where this is the active filter. Okay. Next. So the entirety of the lab is basically to change the frequency and then see if the gain has changed at all. So these are my results here. Okay, and then this is my graph. This is the graph that shows the values. So this is a low pass filter where it allows the lower frequencies from here all the way here to be in the active region. So the active region is around this part before it starts to fall down. Yeah, so it only allows this component, these frequencies to be in the range, while higher frequencies are rejected. When changing the resistance of the potentiometer, you can see that the graph changes accordingly as well. Now, what happens to the waveform when it's changed to 1 kHz instead? As you can see, the input is 200 millivolts while the output is 4.8 volts. Okay, so let's do a quick recap. The first part is an amplifier and a bandwidth, and contains a bandwidth. For example, a weak signal enters through here, and then it gets amplified into a bigger signal. It also gives a bandwidth where there's only a certain values are in the active region. Secondly is to here, the second part where it's a boost. This has a potentiometer where you can actually change and calibrate the signal or boost the weak signals in case that you can, in the situation where it's actually very, very small. So this step is also, the next step is the low pass filter. The low pass filter gives the signal, this choppy signal into a smoother output. Okay, then lastly, this is our this is the main component, where it actually is some sort of speaker. So the potentiometer here is the knob on the volume buttons that we commonly use in our daily lives. Using this, we can amplify this into an output. In the next video, I will show you how it works in the lab. As you can see, when I spin the P1, which is at TP3, it is actually a human input for the circuit itself. This can be used when the input is too small for us to see, and calibration is needed to boost the signal even further than before. As you can see, the P2 at TP5 works the same. However, this is a volume knob, where it actually increases the volume of the entire circuit until distortion. As the graph shows, as the input is 200 millivolts, the output is a high 8 volts. This shows that how a biosignal amplifier works, where a small signal is added into the signal processing circuit, and the output is a much larger one for us to see and visualize.